we have learned that if we multiply two exponentials with the same base, then their exponents are added, or we say that their powers are added, and the base remains the same. So a to the power m into a to the power n is equal to a to the power m plus n. Now what happens if the base are different but the powers are the same? That is what happens if we multiply two exponentials in which the bases are different but the powers are the same. Let us take an example and see. So we have 2 cube into 7 cube, that is 2 to the power 3 into 7 to the power 3, multiplied. So these are two exponentials which are multiplied. They have different bases, 2 and 7, but the powers or the exponents are the same, that is 3. Now 2 cube is 2 multiplied 3 times. So we can write it as 2 into 2 into 2. And 7 cube is 7 multiplied 3 times. So it can be written as 7 into 7 into 7. So this is what we have. Now we have 3 2s and 3 7s all multiplied together. So 3 2s and 3 7s. So for every 2 you have a 7. For each 2 you have a 7. So let's write them together. So this can be written as 2 into 7. We take this 2, this 7. Again we take this 2 and this 7. Now this 2 and this 7. So we have rearranged the terms in this manner. Now let us club these. So this is what we have. 2 into 7 into 2 into 7 into 2 into 7. So we have 3 groups of 2 into 7. Now 2 into 7 is equal to 14. So this gives us 14 into 14 into 14. So this is what we have. So this is 14 into 14 into 14. That is 14 multiplied with itself 1, 2, 3 times. Now 14 multiplied with itself 3 times is equal to 14 to the power 3. So this is equal to 14 to the power 3. Now observe that 14 can be written as 2 into 7. So 14 is equal to 2 into 7. So 14 is equal to 2 into 7. So when we multiply two exponentials with different bases but same powers, then the bases, that is 2 and 7 in this case, they get multiplied, and the power, that is the exponent, it remains the same. So we see the exponent of these two numbers was 3 and the exponent of the answer is also 3. So 2 cube into 7 cube gives us 2 into 7 whole cube, that is 14 whole cube. So the bases are multiplied and the powers remain the same. Now what happens if we have negative powers? That is 2 raised to the power negative 3 into 7 raised to the power negative 3. We know that an exponential number a to the power negative n can be written as 1 divided by a to the power n. That is, this number goes to the denominator and the sign of the exponent changes. A to the power negative n is 1 by a to the power n. So we do this for these two exponential numbers. So we write it as 1 divided by 2 to the power 3. Since we had 2 to the power negative 3, it can be written as 1 by 2 to the power 3 into 7 to the power negative 3 can be written as 1 divided by 7 to the power 3. So this is what we have. 1 by 2 to the power 3 into 1 by 7 to the power 3. Now we need to multiply these two fractions. So we can write it as 1 into 1 gives us 1 in the numerator. This is 2 multiplied 3 times. So we have 2 into 2 into 2. And this is 7 multiplied 3 times. So this is 7 into 7 into 7. So this is what we have. Now once again, we have 3 2s and 3 7s. So for every 2, we have a 7. So we can write them together. So let's write them together and group them in this manner. Now 2 into 7 is 14. So this is 14, this is 14, and this is 14. So we have 1 divided by 14 into 14 into 14. This is 14 multiplied 3 times. That is 14 to the power 3. So this gives us 1 divided by 14 to the power 3. Now 1 divided by 14 to the power 3 can be written as 14 to the power negative 3. Now if you observe, this 14 is equal to 2 into 7. So we have 14 is equal to 2 into 7. So this 14 is this into this. So the base of this number is the product of these two bases, and the exponent of this number is the same as these two exponents. So we can generalize these results. So if we multiply two exponentials with same power but different bases, then the bases are multiplied and the power or the exponent remains the same. So a to the power n into b to the power n is a into b whole to the power n. The product of these two exponential numbers gives us this exponential number in which the base is the product of these two bases. So now can you find this? We have 3 to the power negative 3 into 2 to the power negative 3. These are two exponential numbers being multiplied. We see that the bases are different, but the powers are the same. So we can multiply the bases. That is, we can multiply 3 and 2. So this is 3 into 2, and the power will remain as negative 3. So this is what we have. And this is equal to 3 into 2 is 6. 6 to the power negative 3. So this is the simplified form of this 6 to the power negative 3. Now this a to the power n into b to the power n equal to ab to the power n holds the other way round also. That is, if we have an exponential number in which the base can be written as the product of two numbers, that is, if the base is in the form of a into b, then we can write it as a product of two exponential numbers, a to the power n into b to the power n. That is, we can break this exponential number as a product of these two exponential numbers. And using this, we can simplify many calculations. Let us see how. Say you need to calculate the square of 110, which is 110 square. Now, to find the square of this number, you need to multiply this 3-digit number with itself. So this will give you 3 lines of multiplication, and then you have to add them. A simpler way of doing it will be writing this 110 square as 11 into 10 whole square. Now this is in the form of AB to the power n. AB to the power n can be written as A to the power n into B to the power n. So let us take 11 as A and 10 as B. So we can write it as 11 square into 10 square. Now we can easily find the square of 11. It is a 2-digit number. So we can find the square of 11. It will be 121. And the square of 10 is 100. We know 121 into 100 is 12100. So using this, we can simplify many calculations. Now let us find negative 5 to the power 2. Negative 5 to the power 2 is equal to negative 5 into negative 5. That is negative 5 multiplied twice. Negative into negative is positive. And 5 into 5 is 25. So this gives us 25. Now negative 5 to the power 2 can also be written as negative 1 into 5 whole to the power 2. So it can be written in this manner. Negative 1 into 5 whole to the power 2. Now this is in the form of A into B to the power n. So we can write it as A to the power n into B to the power n. So we can write it as negative 1 square into 5 square. Now negative 1 square is 1 into 5 square is 25. So this gives us 25. Now let us generalize this. We already know that if negative 1 is raised to the power n, then we have negative 1 if the power is odd and positive 1 if the power is even. Say we have an exponential number, negative a raised to the power n. Now this can be written as negative 1 into a whole raised to the power n. This is in the form of the product of two numbers raised to the power n. So we can write it as negative 1 to the power n into a to the power n using the law which we have just learned. So this is what we have. Now there are two possibilities for n. Either n will be odd or n will be even. So there are two possibilities. When n is odd, this will be negative 1. So when n is odd, then negative a to the power n will be negative 1 into a to the power n, which is equal to negative a to the power n. So this is what we have. But when n is even, then this will be plus 1. So this will give us 1 into a to the power n, which is equal to a to the power n. So this is what we have. So if we have exponential numbers with negative base, then check for the power. If the power is odd, then it can be written as negative a to the power n. If the power is even, it can be simply written as a to the power n. That is, we can take the power outside the bracket, and if n is even, we make it plus 1. If n is odd, we make it negative 1. So now can you simplify this? This is negative 7 whole raised to the power 68. We see that there is a negative base, the power is even, So we'll have a plus sign and then 7 raised to the power 68. So this is simply 7 to the power 68. Now we have 2 square plus 3 square. Can we write it as 2 plus 3 square, which is equal to 5 square? Can we write it like this? Well, no. This is not correct. We cannot take this exponent common. We can do this only if two exponential numbers are multiplied, then we can make it 2 into 3 square, not when they are added. So if two exponential numbers are added, we cannot add their bases. If they are multiplied, then we can multiply the bases if the exponents are the same. So now let us see what we have learned. When two exponential numbers are multiplied, there are two special cases. First is that base is the same and exponents may or may not be different, but bases are same. So if two exponential numbers are multiplied with the same base, then the exponents are added. But if bases are different, but exponents are the same, this is the second case in which bases are different, but powers are the same. In this case, the bases are multiplied and the exponent remains the same. So when base is the same, the exponents are added, and when exponents are the same, the bases are multiplied. So you should remember it and not confuse between these two.